Welcome to this tutorial, Introductions to Differential Equation. I'm Adetunmbi. What is a differential equation? A differential equation is an equation which involves one or more derivatives or differentials of an unknown function. What do you mean by an unknown function? Okay, let's consider a known function first. Let y be equal to x cubed. Okay, clearly here we can see that y depends on the values of x. So if x equals 2, our y will be equals 2 to the power 3, which gives us 8. If I want to differentiate y with respect to x, this gives me 3x squared. dy dx equals 3x squared is a differential equation. Why? Because 1, it's an equation, 2, it contains the derivatives of an unknown function y. Let's assume we don't know what our y is. So if you are given something of this nature, this is a differential equation. Okay, let's look at other differential equations. You can have the 2y dx squared plus k squared y equals 0. This is another differential equation. X squared plus y squared all dx minus 2xy dy equals 0 is another differential equation. It contains the derivatives of an unknown function as well as an equal to sign. How do you classify a differential equation? Differential equation can be classified based on one type, namely ordinary or partial. When do you say differential equation is ordinary? Ordinary differential equations contains just one dependent variable and one independent variable. For example, the y dx equals 3x squared. The dependent variable here is y, the independent variable here is x. And what do we mean by partial? The partial differential equation contains one dependent variable and more than one independent variable. Here we mean 2 or more. For example, the y dx equals du dx plus the v dx, del v dx. For example, del 2v del x squared plus del 2v del y squared equals 0. So this means that the variable v depends on both x and y. Variable v depends on both x and y. So when you have one dependent variable and one independent variable contained in a differential equation, you say such differential equation is ordinary. But when you have a dependent variable and 2 or more independent variable, you say such differential equation is partial. So that is classification based on type. 2. Classifications based on order. Classification based on order. So what is the order of a differential equation? If you have the ny dxn as the highest order you have in the differential equation, then you say that differential equation is of the nth order. Okay, if I given y equals x cubed, dy dx equals what? 3x squared. This is of the first order. The 2y dx squared equals 6x. This is the second order. The 3y dx cubed gives us 6. this is the third order. So the ny dxn is of the nth order. So let's look at an example. The y dx plus 3x equals 0 is an ordinary differential equation. Why? Because there's only one dependent variable y and one independent variable x, and this is of the first order, dy dx. Dy dx can also be written as y prime. The 2y dx squared plus 2b dy dx all to the power 3 plus y equals 0 is an ordinary differential equation because there is only one dependent variable y, independent variable x, that's just one. But of what order? We have dy dx in the equation, but we also have the 2y dx squared in the equation. So the higher of the two is the 2y dx squared. So we conclude that this ordinary differential equation is of the second order, or order 2. So this is how you check the order of a differential equation. So we have looked at classifications of differential equation based on type, namely ordinary or partial, and also classification of differential equations based on order. So we are looking at the classification based on degree. What is the degree of an ordinary differential equation, or of any equations generally? The degree of a differential equation is the power to which the highest ordered derivative is raised. The degree of a differential equation is the power to which the highest ordered derivative is raised. Let's look at the example we looked at under the order. That's the 2y dx squared plus 2b the y dx all to the power 3 plus y equals 0. Now clearly, based on what you have learned so far, you can see this is of order 2. Okay, so the highest order we have here is this, that's order 2. So the differential with the highest order, the 2y dx squared, is raised to what power? Clearly this is 1. So we will not pick 3 because the y dx is not the highest order here. So the degree of this differential equation is actually 1, and that is the power to which the highest order derivative is raised. So this is an ordinary differential equation, ODE, order 2, degree 1. Now let's look at another example. Given this differential equation, the 3y dx cubed equals the y dx all squared plus exponential x to the power 3. Now, what is the type? Clearly, the type is ordinary because we have just one dependent variable y and one independent variable x. What is the order? We have the y dx here, but that's not the highest derivative we have. We have the 3y dx cubed. So this is the highest we have. So we say this is of order 3, or the third order. So what's the degree? We consider the power to which the highest order derivative, the 3y dx cubed, is raised, and that is 1. Degree 1. So this has given us the type, the order, as well as the degree. This is not all about classifications. Before I go to the last one, the fourth classification, which is very important, we're going to spend more time on that. I'd like to leave you with some questions for you to try on how to classify differential equations. Now, if you have the r dt plus kr equals 0, what is the type? What is the order? And what is the degree? So you just try to fill in this. Number 2, the 2y dx squared plus k squared y equals 0. What's the type? What's the order? What's the degree? Now let's look at this. Number 3, del v del t equals h squared del 2v del x squared plus del 2v del y squared. Number 4, L d 2 high dt squared plus r d high dt plus 1 over ci equals e omega cos omega t. Now, I would like you to try your hands on these 4 questions. Check out for the type, check out for the order, and check out for the degree. I want to look at this special example because it's a special case of getting the degree. What is the degree of this differential equation? The 2y dx cubed equals m on h, then the root of 1 plus the y dx all squared. So we are given this. So what is the 2y dx squared equals m on h square root of 1 plus the y dx all squared. What is the type? The type is ordinary because we have just one dependent variable, the one on top here, y, one independent variable, x, so the type is ordinary. So what's the degree? Let's check the order first. What's the order? We have the y dx in this equation, but this is not the highest derivative we have. We also have the 2y dx squared in the equation. So because this is the highest derivative we have, so it's of order 2. But what is the degree? Though we have the 2y dx squared to the power 1, but yet we can't conclude. Why? Because we have fractional power in the equation. Anytime you have a square root or another fractional power on any of the derivatives in any part of the equation, you have to simplify that before you come to conclusion of what the degree of that equation is. So how do we remove the square root here? Let's square both sides. When we square both sides, we're going to have the 2y dx squared all squared equals m squared on h squared. Then the square root is gone. 1 plus the y dx all squared. So this is what we have. So here there are no fractional powers, and we know what our highest derivative is. That is the 2y dx squared. So the 2y dx squared is raised to what power? Is raised to the power 2. So we conclude that the degree of this differential equation is 2. So we've been checking the type, the order, as well as the degree of differential equations. These are the first 3 classifications of differential equations we have. Let's check on the other classification we have, which we actually take some of our time because it's very important, and that is linearity. Differential equations can be classified based on linearity. And it's either linear or non-linear. The question is, when do we say differential equation is linear? Differential equation is linear if the following conditions are satisfied. Differential equation is linear if the following conditions are satisfied. The first one is this: dependent variable and its derivatives must be of the first degree. The dependent variable, that's the variable at the top, and all its derivatives must be of the first degree. Secondly, there should be no product of the dependent variable and its derivatives present in the differential equation. There should be no product of the derivative and its derivatives present in the differential equation. Number 3, there should be no transcendental function of the dependent variable or its derivatives present in the equation. What do you mean by transcendental functions? The log of the dependent variable, the trigonometry sine, tan, cos of the dependent variable, and the exponential of the dependent variable. They must not be found in the differential equation. So if all the 3 conditions are satisfied, then we can conclude that such differential equation is linear. So let's look at examples. Given this differential equation, the y dx plus y equals x squared. Now let's look at this clearly and carefully. What is the dependent variable? That is the y. What's the independent variable? X. So the dependent variable is our y, that's standing alone, and is of power 1, that's degree 1. And our derivatives of y, that's the y dx, is of the first degree. So the first condition is satisfied. Number 2, there should be no product of the dependent variable and its derivative. So y dy dx is not in this equation. So we still say this is linear. So let's consider the third condition. There's no log y, there's no sin y, there's no tan y. So I can conclude this is linear. Number 2, 3x squared y prime prime plus 2 ln x y prime plus exponential xy equals 0. So let's look at this. The first condition, the dependent variable, that's our y, and its derivatives. The derivatives we have here include y prime and y prime prime. Y prime is the y dx, y prime prime is the 2y dx squared. Okay, so y is of power 1, y prime is of power 1, y prime prime is of power 1. So the first condition is satisfied. Second condition, there should be no product of the dependent variable and its derivatives present. There's no y is not multiplying derivatives, so we are safe. So it is still linear as at now. So let's consider the third condition. There should be no transcendental function. Wow, we have ln here, but there's no cause for alarm. The ln is not for y, rather it's for x. Is the independent variable. The exponential here is not for y, is for x. So there's no transcendental function of the dependent variable present in the differential equation. We can conclude that this equation is linear. It's linear. Number 3, the y dx plus y squared equals 0. Let's consider the conditions. The first condition is that the dependent variable here, you can see clearly, is y, should be of the first degree. Now this is 2. So since the first condition is violated, you can conclude it is non-linear. You do not have to wait till you check the 3 once 1 is violated. Number 4, the y dx all squared plus 3y equals 0. Now you can see that the dependent variable is of the first degree, but derivative is not. So the first condition is violated. This is non-linear. So these are things you need to consider anytime you are checking for the linearity of a given differential equation. You have to check whether the dependent variable and its derivatives are of the first degree. Check whether there is a product of the dependent variable and its derivatives present in the equation, and check whether there is a transcendental function of the dependent variable and its derivatives or its derivatives present. So if the dependent variable and derivatives are not of the first degree, if there's the presence of the product of the differential of the derivatives as well as the dependent variable present, or we have the transcendental function of dependent variable as derivatives, then we say they are non-linear. Any of these conditions violated, you conclude that the equation is non-linear. Okay, let me leave you with some questions to try here. Classify the following differential equations. Classify the following differential equations. The 2y dx squared plus k squared x equals 0. Now let's look at this together. This looks somehow. What is the type? What's the type? This is ordinary. Do you agree with me? Yes, because we have just y and x involved. One dependent variable, one independent variable. Okay. What is the order? Is of order 2. dy dx, the 2y dx squared, that is y prime prime, is the highest derivative there. So this is of order 2. So what's the degree? So that the 2y dx squared is raised to the power 1. So that is of degree 1. So what's the linearity? Okay, here we have to consider all three conditions. The first condition, the dependent variable and its derivatives must be of the first degree. Okay, what's the dependent variable? We have concluded it is y, because y is what we have on top here. Okay, but where is y? Y is out of this equation, so we can see clearly that y is of degree 0, because y to the power 0 gives us 1, provided y is not equals to 0. Then it means y is of degree 0 here, so it has violated the first condition. So this is non-linear. It is non-linear. So this is what I expect you to do when I ask you to classify the differential equations, or your lecturer asks you to classify differential equations. They expect you to classify based on the type, the order, the degree, and the linearity. Okay, let me review these questions to tackle. Classify the following differential equation just as I have, based on type, degree, order, and linearity. 1. Y prime prime minus 3y prime plus 2y equals 0. 2. Y prime plus p of x y equals q of x. 3. The y dx plus xy squared equals 0. 4. The 4y dx4 equals omega x. 5. X plus y dx plus 3x minus 1 dy equals 0. And 6. The 3 omega dx cube all squared minus 2 the omega dx to the power 4 plus x omega equals 0. I hope you will find this interesting solving. If you have questions or anything you want to ask me, you can send it to my contact, which will be provided. I hope you join me in the next tutorial. We'll be looking at solutions of differential equations. See you then.